So I put a load of ceramics on there. Yeah, I've still got about half as many to go back on. There's a load up here that haven't been done, and one or two down there. But we've got a spread, and some up here, a spread of ceramics. And I've also installed 1100 microfarad in the position there too, because the power comes in around this area, I think, on either side actually, just to boost, you know, hold, store a relatively large amount of capacitance, that's, you know, power. I'm now just shifting my attention because I'm fed up with doing ceramics. Put in some IPA here just to see if we can dissolve this rubbery glue that's, well, it's lost its stickiness. It's just like a horrible browny mess. I'm going to stick some new rubbery glue underneath it. Yeah, it kind of looks like, I don't know, really ancient hot melt glue maybe. You can see it's kind of, it's like rubbery. Ugh, but it's gone yellow and brown. And anyway, if I peel this off and get some rubbery glue underneath it, I could use hot melt glue, but I don't want to heat the crystal up. I tested both these crystals out for jitter, you know, in terms of the grounding of the can. The one over there's got positions, and this one might have as well. Yeah, it has positions for a strap if you wanted to strap it down to the board. But having something that couples the crystal to the board, if you know, if jitter's not an issue, helps with vibration and stuff. Because crystals are subject to, well, vibration. Vibration can affect them. The right frequency of vibration can crack them. Fixed a number of portable devices in the past where they've been dropped, and it's nothing but the crystal that's the fault. The crystal just stops working because of the impact. Yeah, anyway, this is not going to have to be dropped and have an impact, but the point is, I may as well just secure it similarly to as it was before. Alright, so I'm just going to get some of this rubbery glue under there, don't need much, and put the crystal down flat like that. I'll put something on top of it just to weight it down probably. You could of course just like, you know, put it down and then just press it marginally that way, because you reform the legs. There you go, sort of sitting a bit flatter there now. Anyway, that looks a bit cleaner. Yeah, and I tested the one down here for jitter as well. It's yeah, it's not been stuck down, that one, or if it has, the glue, yeah, there is a bit there. I think the glue is long since gone. Someone's peeled it off previously. You can see there's a cap in every position, and I've tactically chosen to put 100 microfarad where there's a bypass position there, 100 here, we've got the 1000 here, 210s, which we didn't even have a system working until we did that down there earlier on. We need to do this bit. I'll recap this when I try and deal with the audio section. There's a resistor there I'm just going to measure that looks a bit odd, like it's got a split on it, but I don't know what it has or not. It's right on the edge of the band, you know, the body of the package, you know, it's got like a little line around it, and I can't work out whether it's supposed to be the tolerance band or what. Anyway, let's try it now. I've tried it as I've done different bits here, you know, so I did like a few up here, tested it, 3 or 4 up here, tested it. I haven't tested it since I did some of the ones here and a few here. So yeah, the reason it's worth doing that is just in case you were to accidentally bridge something somewhere, or install a cap that adversely affects things. Yeah, so we've still got this line here. If anything, that line's more solid now, rather than being really, really flickery. But one thing I would say is it's been a lot more stable. I mean, like a hell of a lot more stable. It comes on every time you switch it on now. Previously, there were a few times where I switched it on and I'm like a black screen. What's going on? Switch it off and on, off and on, off and on. I'd be messing around, off and on, and eventually it'd suddenly come on. And I'm like, what was that? I think it's the lack of capacitance on the board, you know. I really do believe that was the issue, because it's solid now. As I've been doing the recap, I've not had a repeat of that, and I was having that issue up until like I'd got about 20% of these caps on there. And the picture looks a lot clearer as well. It's just this flickering line you get at the top with certain usage of sprites, I think. It's, I don't know, it's a bit mysterious. Yeah, you saw it then, like a little line that just occasionally pops in. But those are the sorts of deficiencies you get in bootlegs. Punisher was very similar to that in different ways. That you got tiny little glitches every now and again. and it's probably a relationship to the family of a specific 7.4 series in a key position. It's not right. It probably needs a 7.4F or something like that, or it may need a capacitor putting on a specific signal, or even a Schmidt or something. I don't know. The bottom line is that's what it'll be. But I mean, without schematics, I don't know, I've got no chance of understanding where that could be on the board. It could be anything on here, really. Someone with a lot of time and patience could work that out. But I bet if you got 10 of these bootlegs of this revision, you'd see that line there. I'll bet on that. Having said that, you never know. It could be something else, like something that caused the fault here, or a fault elsewhere, or something that is just, you know, slew rate is slow transition on one signal just every now and again, maybe. But it's always at the same point in the screen, so I don't think so. I think it's a design deficiency, or an implementation of the design, someone cutting corners. It always makes me laugh that these boards that are cheaply thrown together like this, someone goes to the time of going, or tries to save time by going, let's not fit the decoupling caps and test it. Oh, it works, let's just not bother fitting them. That'll be alright. And you're at the mercy of your power supply more than anything. Any slight deviations in voltage level and it's game over, it'll freeze, it'll crash, you'll get unexpected behaviour. These must have been terrible for reliability in the arcades, but I don't know, maybe not. I just feel a lot better for having fitted all these things, despite the fact it's a crusty bootleg. You know what I'm like, I put my heart and soul into anything I repair generally. So if I'm going to go to all the time I've spent on this, why not just go the extra bit, go the extra mile and do some of the things we've done. Anyway, so we're waiting for the parts over here. I will just switch it off and put the meter on resistance mode. And I'll label the ROMs up properly as well, like these ones here, it's like 9, 10, 11, 12, and I think you've got like 1, 2, 3, 4 or something. And then it's obvious that anyone looking at a ROM set can work out what ROM's what. Because, well, as things stand, it was very difficult for me to work it out. So we're on resistance mode. Yeah, there's resistance down here, it should be 1k. Probably is. Yeah, 98 something. That one's 470. Yeah, it's okay. It's just there was like a little mysterious line on the very end of it. I thought, is it correct? It hasn't. Because the sound issue is still unexplained, isn't it? You know, like, is it this? You get no sound at all without that PAL? If it is, we're knackered. I'll have to try and reverse engineer somehow and come up with my own code, I don't know. The ROM, we know, is alright. I think the Z80's working, because it does sort of start and stop the sound as if this is doing something. It could be the RAM, maybe, but I piggybacked that and it was exactly the same. If it was the YM3812, there's two aspects to the sound here. We've got that speech chip here, you know, the Oki one. You hear samples but not the music. Considering all the music's balked and I think all of it is digital, I think this is going to feed to a DAC, and I think that maybe feeds to a DAC, and then the DAC feeds to the op amp. I'm guessing it's going to be that. That's going to be the first thing I swap when it arrives. But I could be wrong. And there could be some supporting 7.4 series around this area that's feeding, you know, it's controlling the address decoding or something. I suspect it's that, though. I suspect that's controlling the address decoding for these few things that are around this area. That's what I think that's doing. And, you know, the more I think about this now, and I'll check the data sheet in a minute, the more I think about this, I don't think that's going to be the fault. I think it's going to be something that's in common with the sound and music side, with the samples, which means maybe it is this. Maybe it is some address decoding, because I failed to see. You get some interesting noises. I'm just listening. It's like a weird noise there. Yeah, I failed to see how all of the sound can be completely balked, unless the op amp was faulty. But we're hearing what sounds like a problem serializing data. Yeah, you know, the serial data that comes across from the, you know, into the DAC. Yeah, two components is the point. So, address decoding. I don't know. You see, I did try piggybacking some of the things nearby, like there's a 138 there. Don't know, there could be a couple of faults here. Maybe there's a problem with like demuxing or something. Could be two different issues. You could have a problem with the music side and a problem with the samples. I don't know. And one final thought here. There could be a problem interfacing between the CPU side and the sound side. That might be what the issue is. Yeah. In other words, like one of these 245s, a latch or something that passes the data over to the Z80, because you've got a 64K ROM here. I'm darn sure all the game sound is not in that ROM, and it's shared with another PCB, that ROM. So in other words, it's not just Pang, which leads me to think the Pang stuff is in one of these ROMs down here. Yeah, the sound data is being fed across, spoon-fed across the samples and the music to control the YM3812 there. So yeah, I'm going back to thinking about some of these other things. That's palette RAM. Some of the stuff around here is for palette control, but we've got an awful lot of 245s and things down here. There's a 374 there. Let's look what that is. Maybe that 374's faulty. It's a Gold Star. You never know. So it could be a communication, a bit like the Neo Geo, a communication channel to the stuff here. If the wrong data's getting there, that would explain entirely why the two subsystems, if you like, of the sound don't work. I'll investigate further. Yeah, trying to make sense of the audio circuit, it's an absolute nightmare. I just can't trace anything. Trying to find the output enables, like chip select for this, and I just can't find them. The address lines go here. I've started to do a diagram for that. I'm relieved it's address lines, not data bits. I thought it was data bits originally, and I was panicking a bit, thinking maybe the data's decrypted or something or something like that, or I don't know. Something strange happens with the data path through, depending on which device you're communicating with. That would be a bit weird. Anyway, so it's address lines. So that is what I said ages ago, address decoding, I think. But I can't find it driving output enables and things, so it's a mystery. I tried piggybacking the 273 here, and the sound sounds still completely crazy, but more normal. You hear just the odd, like, start of a sequence of tones, like as if some music starts playing, and then it extends into, like, it gets stuck. So, even though it's a different brand to the one that we removed previously, this was like, was it Gold Star? I forget where it is now. That's there, Gold Star, the one we removed earlier, 273. I'm going to remove it anyway, because we've got some more 273s on the way, and I figure I can just borrow the one over here, which will mess the graphics up, and plug it in a socket there, just to rule it out. I'm kind of working my way, logic probing things here. I get weird behaviour on the scope when I scope this, and I think it's just oxidisation on the pin. It's like you scope it and you get a triangle peak, and you straighten up and it goes straight. It's almost like it follows you straightening up, and if you go straight onto the pin, it's square. Yeah. So yeah, I think this tip is dirty, or the pins are dirty, which means you get on an angle and you've got impedance, you've got resistance, you know, attenuation. Anyway, so that's the next thing I'm going to do. I don't think there's a chance this is going to be it. It's unlikely. If it was the same brand, it would make sense, wouldn't it? It's the only other 273 on the board. But anyway, I'm going to do it anyway, just because I'm out of ideas really for the moment, other than trying to follow traces. So I've checked like all the 7.4 series all round this area here, and it's a mystery as to what's going on. I've tried following connectivity. The Z80, its first 80-bit pin, the sixth one from the right here, does go over to this chip, and I think that one as well. I think this might be the data path, I don't know, for these sound chips, and maybe the Z80. It's very difficult to work it out. It probably goes from like here to one of these buffers somewhere. Nevertheless, I scoped this chip. Whilst all the other chips look normal, this one's got like really weird logic level differences. You know, you see like a high up here, and then a little thing down here at the bottom, like less than half the peak, over and over pattern on most of the pins on it. So maybe that's the problem. It's like a 373. This is a 374, but I think it can tri-state. I don't know. I thought the 373 could tri-state. Anyway, I don't have one of those to spare, but apparently it says it's pin compatible with the 373, apart from the tri-stating thing. So I thought, well, I'll order one anyway, and we'll try a 373 now. But I'm just going to use the desolder station again, even though I don't like using the desolder station on this board. And just going to see if I can quickly get this off, and I'll use hot air to free it. And we'll get a 373 on there, in a socket. Right, I'd soldered most of the pins there. There were a couple that folded over, which is always fun. It's really joy when people fold the pins over when they're assembling boards. Yeah, and they're still kind of folded over now. They're really difficult to get up. And of course you can't heat these pads for more than a second or two, or it all starts to dissolve. Right, I'm going to use lights free that. Yeah, the pads are terrible on this. Have I said that enough times yet? If I never work on a board like this again, it'll be too soon. I mean, to be fair, most of the solder got freed up there. It's just those couple of pins that were bent over that were problematic, really. Pretty close to that socket, aren't I? I'll start on this side. It's freeing up. You can hear it. You could see the board flexing a little bit there, so yeah, it was getting a little bit hot. Inspect around for any damage, yes, find the top side there, and get a socket on. So I'm getting nowhere with this. I've spent a few hours, like an hour last night, an hour today, trying to understand what's going on here. There are a lot of things that make it really hard to diagnose, because this board has been really badly laid out. I want to say badly laid out, I mean, like in terms of connections to gates that are unused, they've left them floating. So you measure on the scope and it floats as you imagine it would, like, you know, 1 volt, 1.5 volt, and you're like, oh, I found a fault. And you start tracing, you're like, I don't think there is a fault, it doesn't go anywhere, that pin. So there's a lot of that going on, certainly up here, around some clock gen stuff up here. That's one complication. Scoping around here, I can see, I think the data for the sound system is coming through here. It's like a latch or something, maybe to the Z80, or maybe to these things, or one of these things here. And you've got like a sandcastle thing going on where you've got, you know, peaks midway, you've got a line up here, and then it goes up, down, all over the place. Yeah, that can be a thing with pull-ups and things like that, but it just looks really contention-y to me. And the sound is sounding like contention, almost like it's trying to write to this, and it's trying to write to that. Maybe at the wrong frequency, and the clashing, or something. Something's going on, like, you know, a contention issue, or a frequency, a clock issue somewhere. Like the data's not being clocked through to these two things here, these two devices, you know, through that. I think not in that case. I think this one just goes straight to there, but this has a little DAC, I think. I did pinouts on the GAL here. You know, it's not really a GAL, it's a Samsung part, but it's a GAL. You could put a GAL 16 L8 in there probably, if you could work out the logic from this. Well, it's address decoding. You've got all of the address lines coming in here. A few of the pins on the top side, which are commonly used for outputs, can be inputs, and those are used for address decoding. And then you've got connections to, on the Z80, MREC, you know, when it memory request, you know, access some memory, external, I think, to, you know, whatever, and the refresh pin. So those are going to be used to do the address decoding, perhaps for the ROM. That's one thing. It goes to the ROM output enable, pin 22. So that's what's providing the address decoding for that, this. And it's going to take the address lines into account, these things here into account, and go, well, when we're trying to do ROM access reads, let's enable the ROM. But then you've got connections to the 138, 4 of them, and connections to the 174, 3 or so of those. A pin that I've not been able to work out where it goes. So this is the thing, it's doing stuff with this 174 and the 138, presumably to do address decoding again, yeah, to select which device is selected here, you know, like. And I've just measured the chip select on this at pin 7. I'm trying to think where it goes now. I guess the 138, yeah, the same 138 that this is feeding some things into. So the point is that I think we might have an address decoding fault. It looks like we've got contention that supports that. I just can't see any actual issue, if you see what I mean, on any of the pins. The 138 is a bit fluffy. There's a few pins that again are showing like midway logic levels. If I piggyback it, behaves just the same. Piggybacking doesn't always work though on a fault like that, because when you're dealing with digital data that's getting scrambled and contention issues with a buffer, if you piggyback it, it's, you know, the data's not 100% quality from that point on. In other words, you only need a few glitches here and there when you're doing demuxing and muxing and buffers and things involved to pass data, and before you know it, your data's just garbled. And when it comes to something like this and something like this, garbled data going to these things is going to result in garbled music. So I'm going to take a punt here and go, well, the chip select for this comes from that. Let's remove it. There's another reason to do it. If I remove this, it means I can lift its pin out, which means this has not got chip select, and I can feed a high there. And then if the sound miraculously springs to life, like we get samples but no music, yeah, it's a bit of a clue that maybe the address decoding is going wrong. Something related to this, something related to that. And we've got some sound back. Does that make sense? So even though it's a guess, it is an educated guess. I'm going to remove that 138 because otherwise I'm in the dark. I haven't got a clue. Yep, I am just going to use the tip tinner. Can you see the tip is awful? I noticed that as I've been soldering the last few chips, you put the iron on the solder, it doesn't melt, and it's because it's just so oxidised on the end there. It's not been done in a while. Jab it into the copper braid there. Yeah, contrary to popular belief, that is not just like powdered solder or something. It's, you know, it's got some acidic type stuff going on in it, I think. You can see the tip is now silvery again. Just tape a little bit of foil around the base of the ROM socket there. Just try and mitigate. It's going to slide up as always does. Captain tape pants. Anyway, I'm going to free it with hot air. So yep, and believe it or not, the camcorder ran out of space. I'm filming this on my phone, and just to show you, let me just show you, because you're not going to believe me. You're like, Gadget always just cuts at the inopportune moment. So this is it, 0 minutes. Yeah, the camcorder had filled up. Right, so that made no difference, and I'm having amazing difficulty trying to trace anything anywhere. It's like working out the logic here. The way it, well, without schematics is really difficult. It's just really difficult to trace what's going where. I need to clean around that. It looks awful, but it just needs cleaning up. Anyway, I'm going to get some solder on here. You can hear the solder station heating up. Yeah, I'm going back to using the solder station. I'm alternating between don't like the solder station, then do like the solder station. The desolder station makes it much easier, I think, if you get a bit of solder on here. It comes off really easy, and it's just like a quick suck on each pin, and then I free it up with hot air. It's not quite as easy as a small chip, in that sense. You see that's coming up. Yeah, that side's had it out, there we go, a whole lot came out. And partly because the chip gets hot, as soon as the chip gets hot, the opposite side still holds its heat. Anyway, let's just check that. No lost pads, pads on that side, perfect. That's what I was aiming for, and that's fine. That foil worked. Right, let me clean the holes, get a socket on there. Yeah, that socket went straight on, I didn't even need to clean the holes up. Just fling the PCB and push the socket into position dead easy. I think in retrospect, if this was a board that I just did not care about at all, like the game, I don't think I'd go to this length to repair it. Keeping it as a spare parts board is the best option, you know, to actually taking the chips off it, putting them into your storage might be more productive use of time. But Pang is a really cool game, so you know, I'm kind of thinking it is worth saving. I would play this, but then again, I've got a Mister, and you can do all this stuff on a Mister. You can play the original version of Pang without your bootlegs. Yeah, that looks okay. And the old chip wasn't really exposed to too much heat there. I can use a bit of braid on the pins and it should be good as new to go back in this socket or another socket or whatever. Yeah, one way of looking at it is because we've got the socket on there now, I've freed that chip up to be used as spare parts to fix something else. You know, the more things that socketed, the more things you can take out of this to fix something else. I might do that with the CPU. There, yeah, I might actually get a socket there. Not that I think that's the problem, but well, why not? Right, let's strap on. We've got the ad-lib card here that came from the amazing chap that's donated the Falcon, Matthew. I think it's Matthew. Oh, he's gone blank. Let's get power connected there. So I've not got a chip in at the moment. I just want to see what's happening with it. See if we got any sound at all, because we haven't got the main sound chip there. I'm surprised if there's anything now. Oh my god, it's doing the same thing. I'm hearing the same bleeps. Can you hear that? I've also strangely got a colour problem now, I'm not sure why. Is it just the SCART cable or the... switch it off. I'm not sure if the JAMMA's getting a bit dirty here or it's the SCART thing or what. You heard that then, that sound? Yeah, colour's back. Yeah, so the sound, some of the sound we're hearing is coming from that, which is interesting. No noise when you do that. But anyway, it's a bit of a clue, isn't it? So I've switched that off. Let's get this chip out of this and give that a go. Let's just check it is a 3812. Yeah, it is 3812. So it's an OPL2 chip. Yeah, OPL2. Yeah, there'll be a link to the sound card repair top right. This had, well, I'm not going to tell you what's wrong with it, otherwise it'll spoil the video. Tinned legs on this though, I think this has been reclaimed. And it's got that super dark, like fake looking surface, so it's probably a clone. It's probably not even genuine. So pin 1 here is to the left, so let's get that, hang on, into its socket I think. And press it down. I'm sure it's going to be exactly the same. Switch it on. Yeah, it's exactly the same. One thing I would say is it's not doing... Yeah, here's some tones there. Oh, falling out my ear. Yeah, I think it's more or less the same as it was. Yeah, I would say the behaviour we're getting here is both of these are glitching. Yeah? The samples are like glitching and this is glitching. So, we've ruled that out at least. I mean, it's proven what I already thought though. I already thought that it's either the communication to the Z80, yeah? Because this has its own ROM, I think. So it's not like this is just crashing because of some issue. I don't think it is. I think this is booting from code here. And then a communication channel opens up somewhere, maybe using 174s, I think, or something here, maybe one of these 245s. I'm not ruling out one of those 245s, but I've checked these things. They're all seem to be alright. Communication channel to it, maybe. Yeah, that's the issue. Or, it's not a communication channel thing, it's the Z80, hang on, Z80, trying to use the address decoding to, you know, write to these things. And it's not able to because the address decoding is bugged. I still think we're here. It's right from the very start of this issue. As I looked around a little bit, I'm like, I think it's that. So, I don't know, I can't be 100% sure. Anyway, let's take that out because, well, that didn't fix it, did it? Yeah, anyway, that can go away now. We've ruled out the 3812. In a strange way. Using a board that was fixed in another video. Yeah, so before I get that bad boy back in, I'm going to get some braid, actually, and clean up the solder off the ends there. Just because I don't want to damage that socket, and it will do. If you know, you've got tiny particles of solder sticking out, I can feel them sticking. You know, you plug it in, pull it out, pull the pins at the socket with it. So, it's worth just spending a minute cleaning that up. Anyway, I'll report back. I do it with pliers like this. Just to, it's like a side-on vice, basically. And just go down the pins. Granted, some of them are a bit bent. Sometimes go across like that. Can't get onto it. The right angle. What you really want when you're working on a board like this is one of those testers that has pods. What I mean is, if you check out some channels like Arcade UK, for example, and There was another one, I forget the name of the channel, I'll stick it top left, I can never remember. They've not done a video in years. Is it Retro House Party or something like that? They used to do arcade board repairs, and they had a similar thing where they had a pod. So it's like, you know, diagnostic equipment, and you connect a cable up with a pod. The pod is like, you can stick it in a 68K socket or a Z80 socket, whichever CPU you've got. There's a different pod for each CPU. And then you can stimulate the address decoding. You can like check out the RAM, check out the ROM, read the RAM, write into the RAM, test the RAM, you know, read and write to it, etc. Obviously, it wouldn't really help with this particular problem because other than interfacing with the Z80 up here, maybe you might be able to do certain tests there if you've got the address map. We need something that goes in that Z80 position there and then tests out, you know, can we see the ROM, can we see the RAM, can we see these individual devices, can we read and write to them? Because that's the problem. I think we got both these sound chips sat on the Z80 bus at the same time, maybe. But then you think the Z80 would crash and we'd get halt. But maybe not.
We don't really know what that Z80 is doing, is the point.
There we go, back in. So I'm not sure if it was removal of that chip earlier, but I've gone back to basics here. So I've checked the 2 clock pins top right here, and then I've been looking at the data bus now, because I've been trying to ascertain, where does this get its data bus from? Is it the Z80? Is it from something else? And actually, it's directly from the Z80. First of all, show the clocks. Yeah, you've got 2 clocks up there, upper pins, top left here. They're there, stable clocks, they look good. And then I'm checking these data bits here, D2, all the way up to D7, and everything apart from D2 gets the CPU, and I'm like, I think I found something here. If D2's got a problem, that may explain it, because it wouldn't be getting to this chip either. Maybe that's the fault, but I don't know. It could just be from when I removed that. I would suggest if the sound comes back after fixing D2, that was the original fault. But I mean, how does D2 mysteriously break when there's no trace damage around this area? I don't know. It's a bit strange. Corrosion, maybe? But I don't know. I think this is not going to fix it, and I think it's just something that has been caused by me removing that socket. So anyway, I'm now going to join D2 up. So it's the hang on, is it D2? I need to check now. I'm losing my mind here. Yeah, it's D2. It's the first pin. The first pin on there, I don't think is joined. I think. Yeah, that one's there. The first one's there. The second one, right, stab into the bleeding pin. It's definitely not there. Yeah, so it's the second pin, which I think is D3 actually. Yeah, so the second one is, yeah, D3. So the second one up here wants to go to D3 on the Z80. Unless there's something weird, this is the thing, I could be mistaken. Maybe there's something weird about that pin where D3 doesn't go to the CPU. I think that would be really strange, wouldn't it? To say the least. I think that's the issue. I think that's an issue. I think it's an issue I've created. If I have a look at the trace here. Yeah, it's joined up to the part OK here. Right, bodgily joined a wire up there. Let's now flip it over and see if those first 2 connections are still connected. I'm doubting myself here. I'm thinking there's something crazy going on, like D3 doesn't go there. D3 goes through some of the weird logic somewhere else, and it's not bothered about D3 or something, I don't know. Or D3 is driven by a different chip, you know, that's the point I'm trying to make. Right, so you got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and then the first one. Is there. So, well, D3 is now joined up. What's special about D3? I don't know. Why is D3 not joined up? Should it be joined up? Shouldn't it be joined up? I don't know. And why is the ROM seemingly not connected on that point either, anywhere? So, because you'd think there'd be a connection from here to here and there if they're all joined up, or from here to here and there. Well, I measured from here, no connection to that pin. you know, on this chip. And from here, nothing connect, no, nothing on that D3 either. So, don't know. Anybody's guess. Switching it on, feeling the top, listening to the sound, nothing. Oh, we got sound. Really? Don't tell me that was the fault. No way. I can't believe it. Can you hear that? 5 chips around this area I've had off. But I've also, you know, started to reverse engineer that, and I spent some time thinking about the code for that last night in my head, thinking I need to re-engineer this thing. I don't think I do. We have sound. There's no music yet, so there might be another issue yet. But if I just hang on, put credit in. Hear that? So let's start the game and see if we get any sound, any music. Sounds weird. I'm not convinced we're missing. I'm not convinced we've got all the data bits yet. I need to go listen to Pang. I don't know. It sounds alright. It's music. Yeah, let me just turn it up so you can actually hear it. Let me just press start and turn it up here. Hear that? I'll point you to the screen. Yeah, so the next question is, do we have all the sound? Like the N5205, what does that actually do? Are we missing some samples or something? I feel like we are. I feel like we've got maybe the YM3812 now, but maybe we're still missing something else. I don't know. Anyway, I'll report back. I'm going to play this for a bit. Yeah, I'm convinced we are pretty much there now. You can hear it. So whether the bootleg music's the same as the original official Mitchell board, I don't know. But the YM3812's fixed. So I think we had 2 different sound issues here. This is producing samples that aren't there. So in other words, you know, I think you hear a pop, 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 don't you, where the Pang appears on the title screen. Not getting that. And I still hear occasionally like bits of garbage, as if the certainly when you switch it off, it goes as if this chip here is faulty. It's very common for those to be faulty. I've seen on arcade logs years in the past, like Double Dragon I think has that chip, has 2 of them, doesn't it? And a few of the boards, well, many of the boards have that sound chip there. And they fail, so common. So you know what, I'm waiting for some of those to come. I think when we socket that up and replace that, I think we'll get samples back. But I'm just going to rule out, I'm going to play devil's advocate here and just check if that data bit just happens to go to that chip. If it does, if it already goes there, I'm not going to be concerned. I don't know where the data pins are, to be honest. I think there's like 3 or 4 bits go to it. 4 bits, I think. I think it's like a 4-bit interface. It's really annoying you can't get around there. And this is genius here, isn't it? This fitment of these components, so you can't get anything around here. I'm going to improve that in a minute, because I've cheesed off with it. Now you see, this doesn't go there. So I think it's maybe this 157 is what goes there. We can try that maybe, like from a second data bit. I don't know. Oh God, it's really hard trying to probe things on this. Yeah, so this makes me think, you know, we've resolved an issue with these things here. Strange how the ROM doesn't connect to this, but maybe the ROM is read via something else here, like gets latched in and read, which I don't quite understand how that would work. You know, it's a bit mysterious, isn't it? Like, where does this get its code from if this is not connected upon that data bit? I mean, I can test it again just to rule it out, but maybe it measures easier from from the top side. Oh, it does go there. See, when we measure on the bottom side, we couldn't find that. I don't know why. Maybe it's just oxidized solder points. So yeah, D3 does go to this, and it goes to that now. It doesn't go to that directly. The data bits don't go to that directly. It goes through this, I think. So something gets latched, some data gets latched into this, and then it's fed that way. I think this is why we've got this latch stuff going on here. But we've ruled this stuff out, so it's not those. And this has obviously been a problem all along with that as well. And it's just two different faults, coincidentally. I think that chip's died, and that chip had a missing data bit, which is mysterious, because you know what? I'll show you another time. I think I might know where the issue is, but I measured on continuity and I couldn't see the join to the trace I was trying to measure. So if there is a break, it's broken in two different places. One where it's hardly, it's hardly visible. There's like the via comes out. You've got the via and the pad, and they're just like tiny little. It's like the smallest join. Maybe it's broke there, but I tested that whole trace and it wasn't joined at the other side either. So there must be another break. But if there is a break, it's got to be underneath this. And how does that happen? I don't know. Yeah, I'm back again. And you know what? It did just dawn on me that the point where I was talking about, there's a trace that maybe it's detached from the thing there. It's never been soldered or reworked, but I think it's had a break because it was a pathetic trace from factory. But it goes over here, doesn't it? It goes to a via, yeah? And this is where I measured to go, oh, it's not even going over there. Because I was thinking, is that where it's failing to join here? It may be that this goes over here to this area where the M5205 is, and there's no join, but yeah, there is, actually, so it's not that. It's not that. That isn't where the break is, so I don't know. Strange, isn't it? Strange how we couldn't connect to the ROM either before. I don't know. Right, anyway, I'm shifting the attention now. I'm going to wait for that chip to arrive, but I'm going to remove these things here and replace them, I think. Not all of them. I might just leave some of these caps there. But this one in particular, needs to be dealt with because it's sticky outy, and that one, and maybe even this one. See if we can relocate things a bit better and put maybe a smaller footprint than that. Because, well, it's just a mess, isn't it? So the ground is towards the BIOS on this one. Right, so I've got flux and braid, and I'm going to unblock these holes that way. It's far easier than trying to wrestle with the pads and use a desolder pump or desolder station. I say that as it's not unblocking. It will do if you cut the braid back to the right place. I have really disliked working on this sound section. I've got to try and remember where everything goes, because there's like one or two caps here, well two caps even, that I'm not entirely sure exactly which position they went in. You can see I bent these things back up here. They were potentially short on the chip, you never know. There may be, one of those caps might be doing something on the clock, like loading a clock, and now it's not shorting. It might just work anyway. We might get a socket and put this chip back in and find it works. I doubt it. I think this chip is the fault with the samples. Yeah, it's like now I look at this, things make sense to me a bit more about this area. These caps are supposed to be laid down this way and in there, yeah, and they're not, are they? So in other words, I put 1000 microfarads somewhere over the right there. It would have been a bit beefier than 220, and this one here is doing the same thing. It's like probably smoothing the 12 volt rail, I would assume. Right, that was sheer trauma. Here, every minute of that, it's taking me about an hour and a half to do all that shenanigans. You can see I straightened that out. The solder points on these were weak. There's like a little bit of a ring around the pin because they've been knocked, so they might not even been in circuit. And as I say, one of the legs was short almost onto the chip here, so you never know. It might all just miraculously work when we put it back together, but I'm not holding my breath. And we may now have an issue because I'm not sure whether I got the right cap in the right position here, because there's a position what looks like for a ceramic, and I think this 220 was in there. I don't know if it was in there. How was it working? Does it just need some capacitance in there? Have I put it in the wrong position? I don't know. So anyway, I'm going to now start to tidy it up. We'll ESR check the caps we removed in a bit. There's only 3 I think we took off. 1, 2, 3. Yeah, these 3. I could replace the whole lot. I'm not that bothered. It's like I say, it's a junk board. We're just giving it a second lease of life, and I've improved it slightly with all of the capacitance I've fitted on here anyway. Let's just brush around that bit. I mean, you can tell it's been reworked very clearly, because it's like I said, the pads don't survive. They don't survive at all. Right, so the final thing is just spot cleaning on those things. Right, let's see what explodes. Did I get a cap around the wrong way? So I cleaned up the legs on this with braid and used the... I was seeing a bit of solder there. There isn't. Yeah, I used the pliers to straighten it and cleaned it with toothbrush and IPA. So I'm getting it back into its socket, even though we think it's bad anyway. But we need that socket, hang on, in advance of the new chip coming. So credit. Ow, that's loud. You can hear that. Just like a countdown to explosion. Sounds a lot clearer to me, if you ask me. I think maybe one of those caps wasn't great, but I'm not hearing samples, I don't think. It's just the 3812. Anyway, at least we've got sound after all the work I've just done. That's the main thing. Yeah, 212.2. So suspiciously low ESR, because it's like a no-name brand, I think. But anyway, it seems alright. I'm sure these are going to be okay. Same thing. Very low ESR, 215. It may have been recapped though at some point where someone was trying to fix it before it got to me, I don't know. 10 microfarad, 0.76, so again, okay. Yeah, and I measured connectivity on that little missing cap point down there after the yellow one, in between those 3 things. And it goes to the last pin on this TDA 2003, I think it is, which is the supply pin, and it should have approximately, from the data sheet, 100 microfarad cap and 100 nanofarad. It's got the 100 microfarad in the form of 220, that's what that was on here. So it's just smoothing the supply rail, but it needs 100 nanofarad, so that's going to fit that as well, why not? And yeah, I just made my own little bodgy. I got an old speaker here that was knocking around, got an old cable from some headphones, chopped it off, cable tied it on here just so that it acts as strain relief so that it doesn't pull the wires out of there, and I can just plug this into the JAMMA thing when I'm using it. Just because I find it really irritating trying to use headphones, and now I can actually hear without headphones. It's yeah, it just makes sense, doesn't it? Obviously, a better solution would be, you know, a proper speaker in a box or something. Right, I finally got it on. That was trauma. I drilled the hole out. Bear in mind, on the right side here there's no pad, so I'm going to have to hope the solder goes into the wire. Inspect with the magnifier. I'm not trying to be poetic. Yeah, it has. It's gone into the wire. Just give it a bit of extra time. There we go. At least that's got a 100 nanofarad cap there now. Playing with cottonwoods, and I'll test, and you can hear it coming out of the speaker. So I need to do more cleaning up yet, but you can see I stuck some bodgy labels on. They're not all straight and equally cut and all the rest of it. It just means it's really easy to see what ROM's what at a quick glance, and I've just customised a ROM. I'm just going to put this in here, see if it works. I'm curious, like, has it got a checksum? I've done a modification to it. Will it not work? I'm not even sure I've got the right chip type here. I think I have, because I can't see now. Now I've got a label on the 64K, the ROM image, so I used 27C512. Any EEPROM. Can't get my words out. So it's electronically erasable. There we go, let's get that in, let's see if it works. Switch it on. It's booting. Yeah, see if you can spot the difference. I haven't finished giving up looking at this issue. I still think there might be a fault on it. Don't know. I know what you're thinking. You're thinking, check it out in MAME. You're not going to see that in MAME, because it's just basically interpreting the ROM in the, what's the word? You know, the way the logic is recreated in MAME. You're not going to get glitches like that, whereas you may do on a bootleg like this. But I'm not sure whether that's like a deficiency in this bootleg. There you go. Gad was here. Yeah, I just customised the high score table. It does of course mean that if someone dumps that at some point, they're going to think it's invalid. I'm going to stick the label on that. I'll remove it from that. I'll stick it on there. Yeah, it's just customised for me. But anyway, the point is that could be interpreted as you know, another variant of the ROM set now, shouldn't it? I really should submit that to one of those websites, you know, that keeps track of the ROMs, ROM ident or whatever. But yeah, it's not really worthy of being classed as a variant. And the high scores are not saved anywhere here. You know, there's no battery backup or anything on this, or non-volatile RAM. So between power cycles, it loses the high scores. One interesting thing, and I thought it was related to the sound, and I'm sure it is, but I can't work out how. And it might still be that we have a fault here, but well, the sound of music sounds alright to me. And that's this chip, I think, if this 2373. If you remove it, it works just the same. Everything works. The controls work. It sounds okay. You can coin it up. You can play a game. The sound of music is normal, as far as I can tell. So, like, what does that 273 do there? I've got no idea. It's bizarre. That's a new chip, by the way. It's not like there's a fault with it, and that's why removing it doesn't make a difference. I don't know. It's bizarre. Absolutely bizarre. So I'm waiting for a few more chips to try and rule out that graphical artifact. You know, that little bit of noise that appears in the top of the screen there. But I've checked so much around here, both with the logic probe and the scope. The chips I'm waiting for are these ones top right here. I think it's a 74. Let's have a look. Yeah, 74LS194. There's 4 of them. Maybe one of those is a bit glitchy, but I don't really know how that would translate to a bit of noise in a key part of the display. You might be more inclined to think RAM. I don't know. This is why it's nice when RAM's socketed, because I could swap those around. I might just do that anyway, as just something to do, if the chips up there don't, you know, resolve it. And the same with that one. I may just piggyback, you know, not piggyback, socket all 3 of those. Maybe even those 2, but I know that these are colour RAM. I can't see how colour RAM would cause that graphical artifact. Because it's black, I couldn't understand if it was garbage coming back at different points, or it was consistently those bits missing, but they're not. It's more likely to be a logic thing, I think, rather than RAM. Yeah, a bit of UV solder mask there. It's blobbed on a little bit, but anyway, just get some UV on it and some hot air. God, I'm blinding myself then. Yeah, I'm now going to clean this again, the JAMMA edge. The solder coated. It's not like silver or nickel, you can tell, because it's like super oxidised there. But in my mind, they shouldn't be solder coated. Because when you solder coat something like this, you add resistance basically. It oxidises really, really easy. And you add resistance. Right, this is weird. After all that clean-up work, it now doesn't power on, and we've got a short across 5 volts and ground. Dead short, 0, 0, 0. How have we got a short? Oh, it never ends, this repair. So, the point that was shorting was the ground point on this panel down here. It was leaning across the trace next to it. Hey? Sounds different. How does it sound different? Right, I solved the sound instabilities. 2 more wires were sheared up around there. What I mean is, where you got a pad that was mostly disintegrated on the underside, I was convinced maybe the solder's not coming through to the top side. The ground was one of them, and the other one, I forget what it was. It was where the pad was hardly there, and there was a trace coming from it, and it was joined. I measured connectivity. It wasn't. That was the issue with that. So it was dead simple, but it took me ages to work it out. So the thing I've done today is install a pin here, because there's an extended profile there for a large chip into the ground point, so that I can put my multimeter and my scope and everything, logic probe, onto that ground point there. And I've just put a pin on the Z80 here, on the halt pin, a wire, this wire coming off. And it's just so I can pause it. Let me show you. Because what I want to do is see, isolate the CPU from things here. See, does the video issue appear when you halt the CPU? And, well, as you see, hang on, just wait for the title screen to come up. No, look, see the line? You can actually pause it there, I think. Maybe you can't. I don't know, I can't get it to pause with that corruption. I'll just try this a few times, see if we can see it. Because that would indicate maybe RAM. Or if it's coming across via a register, but the point is, I can't pause it with that black line over it, which tells me it's noise at the point the data's being passed rather than RAM. Does that make sense? Because, or even a register. If that was in a register, yeah, even though the CPU's not processing here, what it is doing is still outputting video. So in other words, the video subsystem is still getting the required clocks to go, right, draw a sprite here, draw a tile here, blah blah blah. So we're getting the same thing displayed while the CPU's halted. The CPU's not responsible for driving the video output. We're going bit by bit here. Oh god, honestly, it slips off it. The point is, I can't pause it with corruptions. So that is kind of giving me a belief that registers are alright, that hold and pass that data to the video subsystem, and I think RAM is alright. So it's kind of like some multiplex. Mind you, it can't be multiplexing. It's like, I don't know, the data changes though, doesn't it? So in other words, no, but it's not changing there. This is the thing I'm having a hard time understanding. The sprite is the same. So why would we get those little glitches? They only appear when released just for a split second. It's noise on the video subsystem though, isn't it? Or is it? Is it because the CPU's not running? We've not got some glitch that's passing across somewhere. How would the CPU interfere with the video? Yeah, and for those people that couldn't understand why the board started working in, I think it was part 1, after we replaced these caps here, I was theorising that one of these was on reset. And yeah, coming to just test this now to prove it. 1, 2, 3, 4, 5. The 6th one from the top right here on our main Z80 goes to this logic gate here. It's hang on, 3 pin 6. I think it's an, oh actually that is it 32, I think it is. Yeah, anyway, it comes from there. This cap is, and there's a diode there. Can you see that diode? As soon as I saw that diode I was thinking maybe resets down here, and I think that's what it is. I think the cap, and I can't get onto it from here because it's like right under the thing, isn't it? Oh, so annoying. The ground of that cap, the one that was missing, obviously connects to the ground of the supply. Yeah, it's this thick rail here. The positive side though goes to one of these pins here. I forget which one. Is it that one? Yeah, dead short, 000, pin 2. Yeah, goes to pin 2 on this. So it is the reset. This is exactly why it wasn't working. We know that pin 7 is goes to the reset over here, you know, on the CPU. Pin 2 is where it comes in. Let's just see if the diode goes there. Yeah, it does. The diode goes there. And resistor goes to it as well, one side of it. And the other side obviously probably goes to the supply. So we've got a time delay for the reset. You know, this cap here is charged up by this resistor, and this diode sits across it, reverse biased, presumably. Yes, it does, looking at that. Yeah, so this is the reset circuit here. This chip, this cap, diode, resistor, those few components there are what give you your time delay of your signal goes it goes low for a short period of time to bring the Z80 out of reset, and then goes high. And if you switch the power off, that high gets zapped, so that when you switch it on you've got a low, and then it charges up and goes high. At which point, you know, this then changes its toggles the output to a high here, so that this comes out of reset. So there you go. That's the explanation of, in part 1, why that left hand side cap there was the, you can argue it's the Achilles heel on this. When these boards are being thrown around, you damage that cap or lose that cap, the board's not going to boot. And it does explain to me why, well, it wasn't booting when I got it, because the sticker that was on there suggested there was just some graphical issue. But as we know, there were a lot more than graphical issues. There's a couple of graphical issues, the sound issue, general issues with the way the board had been assembled and stuff and thrown together, lacking all of these bypass caps, and obviously a sound fault as well. And the final point here about the minor graphical glitch, it's like a little flicker there, a little flicker there, and obviously when the pang bit comes up, let's just power cycle it. In the P here, the few little bits of noise when it eventually gets there. This stuff here, I actually think that that's the wrong 7.4 series family somewhere on here. There's one chip where the time's not quite right on an edge. Yeah, it could also be that there is a fault, that one chip has got a wee bit of a glitchy gate on it somewhere that's causing that issue. It's impossible for me to try and dial that in and work out where is it on the board. And I've tried piggybacking obviously around the sprite area because it is sprite related, this issue, and I can't influence it whatsoever, which tells me it's probably the family, the design. It probably, if you could identify exactly where it is, and this is where you really need to do logic analyzer captures really, to see if you can work out where that glitch is occurring. But then you need to understand the architecture. It's overall looking at a logic analyzer capture, say, of the sprite data, but see, if you don't know what you're looking for, you might not spot it. Scoping things may help reveal it, but it's there for such a short period of time. It's very hard to localise, to work out where it, where it sits. Again, if there were full schematics for this, I could look at the schematics and maybe theorise there and dial in on an area and focus, focus where I think, the issue might be. But it's the sort of thing that, because of the way this is being designed, it wouldn't surprise me if the wrong 7.4 series has been put there. It needs an F74, a 74F instead of a 74LS, or a HC or an AC, or AS that is, or something like that, something where it's got a faster switching or something. In theory, I could find that piggybacking if I got AS versions of the chips where I thought was an issue and try piggybacking, and I may see a change in behaviour there. But the game works. I played this for hours and hours and hours. I'm talking like, I probably spent 20 hours playing around with this. since we got up and running, and it's solid, absolutely solid. It's just that graphical glitch, but that's the sort of thing you get with bootlegs, because the attention to detail is not there. Look at the Punisher repair. There'll be a link top right to that in this video here. Yeah, the fact that all the bypass caps were missing and no electrolytics on here, other than the 1 or 2 down here, one for the reset and a few for the audio. Anyway, you can see it. I think the board came a long way through this series. I'm not ruling out there'll be a 4th part where I try and localise where that glitch is occurring, but I just think that that's a design thing. I think I could spend the next 6 months trying to work out where that is. I'm sure I could. If I wanted to, I am sure I could fix that glitch. The obvious way, like I say, is to get some AS series, 74 AS chips, and focus on the stuff around the sprite area, around here, and just remove them, socket them, and test, and then go, oh my god, I found it. That's probably an easy way of doing it. Time consuming, yes. Costly, potentially, because you're going to need a load of different AS74 series that you may not use elsewhere. And likewise, I could start scoping to try and work it out. Now, one of the issues with scoping on this, and I mentioned it earlier in this video, or in the series in general, is there are lots of bad design practices. Again, there are lots of pins on gates that are not used, just flapping in the breeze, just floating, not connected to anything. So you start scoping, you're like, oh my god, I found a weird logic level that's like halfway. Oh, now it's ground. Oh, now it's 5 volts, so it's in between, it's floating around. Ah, there's a fault there. And you start doing continuity tests and trying to follow the traces, and 10 minutes later you go, oh, it's not connected to anything. Why didn't they connect that gate to something? Yeah? And that's the problem, the inputs on lots of 74 series are just floating, yeah, and that might be the issue why we're getting this glitch as well, yeah, because we're getting some parasitic oscillation, oscillation that starts, because that's what happens with 74 series. If you don't, say, ground or put 5 volts into your inputs on 74 series, and they're just left floating, they can start to oscillate when various other things go on inside the chip. And I bet that's what it is as well. That gives me an idea. Maybe there will be a follow-up, because I might focus on the chips around here, find gates that are unused, to start just pulling the inputs low or high, and go, oh my god, I fixed it. It's just this input on this gate here or something. Do you see what I mean? So that might be why we're getting those lines. Yeah, and the issue there with it not powering up when I thought I'd done something wrong to the board or something, it's this JAMMA. Just pull this JAMMA edge off here. Just let me just try and show you this. The connector is wider than the PCB, just by a millimetre or 2, which means if you have it, let me show you, if I have it aligned to the bottom here, so the PCB is right to the bottom edge, and try and switch it on, doesn't come on, the power supply switches off, the power supply goes into shutdown, because, and you could see that there, because the LED didn't, yeah, you can see the LED, the short, 5 volt and ground is shorted out, so you have to have this with this adapter up that way, yeah, aligned with that top edge, and then if we switch it on, it comes on. Yeah, and the dip switches, I've changed them there, so it's now 1 coin per credit, which you can hear there. And the final point on the sound side of things, you can hear that's working there. It was crazy, really, that you'd have a broken trace between, I think it was one of the data bits, wasn't it, between the Z80 and all of the stuff around the sound side of things, the sound circuit there, the subsystem. Yeah, it's disappointing that I ended up having to, working around like this, in a circle, socketing things up. Because, not that, because that was already socketed, but we got 1, 2, 3, 4 chips there where I'm like, I could see that it's related to the Z80. I can see it's related to the subsystem of handling, or handing data over to the Z80, and from the Z80 to the things around it, these 2 things here. The only reason that's socketed was so I could test the replacements, and they all work, by the way. And the YM3812s all work as well. But it's crazy that they have that broken trace, because there's no damage on the PCB at all, none whatsoever. That must have just burnt out or something, or corroded. The via, you saw what happened earlier on one of the chips on the right side there, where when I came to solder something on, the pads are so close that when you've desoldered it, unsoldered subsequently, the solder can just leak across from the pad onto the via. The things are so close and they're assembled so badly. The pads are absolutely crap on this. So maybe something like that's happened over there, where the board wasn't very good from the initial manufacture, and the trace just gave way on that data bit. But that's like a really hard thing to find. Yes, a bit of egg on my face, because you know what, if I'd scoped around the data bus on here, which I did actually, I'm like, the data bus looks alright, but if then I'd done the same thing, data bus on here, clocks, voltages, clocks, and then data bus, if I'd have followed those steps, these 4 chips here, I wouldn't have sockets, I wouldn't have needed to take them off, and I would have spotted that actually on one of these things up here, the data bus is doing nothing, it's floating, it's no connection to it. But I'm not entirely sure whether I'd been able to identify that, because certainly, say with a ROM, for example, when you're trying to read from a ROM, where's the ROM here, it's going to respond no matter what. So, do you see what I mean? So it's like, how do you know you've not got anything there? I certainly didn't see any strange activity on the data bus on this side. Maybe I just wasn't looking close enough at that data bit. But you see, because there are other things that data bus pin is connected to, like some of the stuff around here, we were probably seeing some activity from some of those things. So that's the thing, you can be scoping something and not really see a problem. Yeah, logic analyzer, you would do. Similarly, if you could one step at the Z80, with a pod or something like I showed you in the previous video at the end there, if you could one step the execution, then you could make sense of that pretty easy with either a logic probe, a scope, logic analyzer, etc. Because you'd step and you'd see certain activity on certain, the data bus would be a certain state, but one pin would just be either floating or not doing anything in terms of, if you were checking its destination, where it's communicating to, etc. And you can compare, is that data bit getting across to over here? And you'd be like, oh no, it's not. Here it's a high, over here it's a low. But again, not the sort of thing you would expect, is it? I've never come across anything where a data bus connection's just broke for no reason somewhere underneath these things, when none of those things had been removed as part of any repair attempt. And I pretty much played this all the way to the end, just about, like very near the end. Putting a lot of credits in. It's funny, Pang used to be one of my favourite games, and having played the heck out of this, it's now one of my most hated games. What I mean is, like, the home versions I think are good and they're a bit easier, but this I just find really difficult. I die and die and die over and over like that. It's like if this was the ST Omega, that wouldn't have happened. I don't know what it is. I think it's harder, and I've changed the dip switches. It's on easy difficulty now, and I'll explain those dip switches in a minute. And I'm going to label up the board, I think, a bit more than it's already labelled up, in respect to the fact it's been partially recapped, but also what the dip switches do. One of them changes the difficulty level, and the other one changes how many credits per coin you get. You'll remember that when we first got it working, it was like you had to put 5 coins in for a single credit, which was nuts. But you can have, like, 1 coin gives you 5 credits. You can do the opposite, I think, or something to that effect. I hate that power up. It's like the flaming torch thing in Ghosts and Goblins is what that is. But you do need it later on. Some of the later levels, you want that one that anchors itself to a roof. And there's dip switches there to change how many lives you start with. That's another, oh my god, that's another thing dip switches do, as well as difficulty. Yeah, so up to about here, the levels aren't too bad, but it gets incredibly hard. And to be fair, I don't think I ever went that far on the ST Omega, so it could be, not that I'm crap at it, but actually it's quite hard as you get further on. Oh, just missed the food. Yeah, this flicker in here, don't get it. Why would it just be a top percentage of the screen, a specific number of scan lines? I can't work out if it's almost the same area it occurs in every time. I mean, it's consistent, but what I mean is it consistent every time that each different type of display? So I mean, is it dictated by the sprites that's shown? That's my shield there. those little things are annoying because they stun you. Why have they started appearing? It's like I'm getting too good for it or something. It's like trying to get me back. There's a little bonus there, wheeling its way across the top of the screen. I missed it. Yeah, so with the sound, I can't quite work out if anything's still missing. What I do know is we removed that smaller chip earlier. It doesn't boot without it. You remove the bigger chip, the 3 whatever it is, the YM chip, and it doesn't boot without that either. So seemingly both chips are needed. Or the Z80 on that sound system has a bad day and shuts everything down. It might be waiting for an interrupt or something. That might be why it just doesn't boot when you try and remove them. Yeah, I don't think that's right. You know, it's bizarre, isn't it? The only frame of reference I've got for that is I looked at some footage online of someone playing the bootleg, and they didn't have that. But which bootleg? There's about 5 different bootlegs. If you look up the Pang ROM sets, you'll find there are like 5, 6, 7 different ROM sets for Pang. Yeah, the first levels are fairly easy. Jinxed in here. Oh, this one can be annoying. It really does depend on what bonuses you get. Like that thing, avoid it. It's so annoying, that thing. Sounds terrible for that little tinny speaker. You can connect it to the TV through the SuperGod. I tried that before. You turn the volume down a bit, but, well, ironically, you have to turn it down a bit, then you have to turn the TV up. It's strange. It's supposed to go to a speaker, yet when you feed it into the HDMI upscaler there, oh no, I didn't want that. The volume is really quiet, strangely enough. It's obviously an impedance thing. Oh no. It's like I say, that weapon is the booby prize really until you get a bit further on. That's what I mean about how I'm crap at this game. It's like this at the level I've lost lots of lives in it when I played it previously. I don't want that. Oh, go away. You know now why I put like 100 credits in. I don't think how much it would cost me in the arcade to play this game, because it's so infuriating that you're determined to have another go. I can't really say that about many arcade games. I think if I'd played this in the arcade I would have put all my money in it. It's good about that shield, isn't it? Can't even work out if that sounds too fast as well, you know. It kind of feels like the melody of that music plays a bit faster than I remember from Pang, but then again, I don't think I ever played an actual Pang arcade machine, clone or otherwise. Go up there. Oh, I should have waited. I'm going to deal with that thing first, I think. Oh. Harder than you think. Oh, God. Yeah, did you get the idea now? It's like I get too impatient and I rush into things. Oh. Kind of explains my repairs on my channel as well. It's like, this repair could have been a bit better if I not rushed into things. I mean, coming back to that data bus connection on the Z80 there, it's not an obvious thing to go and check. It isn't. You wouldn't look at that board and go, I better check the data bus on it. You just wouldn't do that. And I still don't know where that data bus connection is damaged. It is not obvious at all. Oh, this one's a pain sometimes not. Yeah, so there might be a part 4 on this, I'm not sure. Post your comments down below what you think about the repair, the faults, the issues that were still outstanding, etc. I'm curious to know. A huge thanks to Glen over at CRG, because you know what, I've really enjoyed working on this. I did spend a few weeks on this, you know, I don't know, half a day at the beginning of the year, and then we picked it back up about a month ago, and yeah, it's come out really clean. You can see the board is really tidy. So yeah, a couple of fixed wires, actually to do with the chips that were removed here to straighten up. There's still one that needs straightening. You know, one of these was really crooked. It was sloped on the board at like 45 degrees. That seriously, that steep. There's one here that's a bit like that. Can you see that? Look at that ram. It goes up on this side, down on that side, so that's bugging me. At some point I may just, you know, I don't know, take the solder off and squash it down flat and then resolder it, or resocket it or something. Yeah, you can see this came out a bit better. It's looking coppery now, rather than solder. I went to town on that with the, you know, fiberglass pen, and then some deoxit and you know, an eraser and all that sort of stuff, just to clean up that. And I tinned these as well. They were looking a bit corroded, those wires that go through to both sides. And those were the ones that I measured when I think it was in part 1, when I was measuring the sink. And I was like, oh, these are really handy, these test pads here. You know, the little wires, the ones nearest the connections here are obviously the ones that are on this side, but the ones that are further up there are the ones on the underside. So you can measure on this particular board all of the JAMMA connections there, you know, to get your sync and your RGB and all that sort of stuff, your inputs, your power supply lines, etc., all from those wires, which was quite nice. I got a label onto there as well, labelled it up here, partial recap, yeah, Pang Bootleg parts recap 2025, but a green dot. And obviously the ones that I have swapped have got a little green dot. You can hardly see them, but they are marked. There's just a few up here that haven't been recapped, including the original 220 there. I should swap that really, but there was nothing really wrong with the caps. You saw that on the SR meter, everything was alright. Amazing that the sound issue there, I'm not going to talk about that again, but it had obviously the fault here for the sprites. Some questionable rework had been done here in the past that we tidied up. Why did I socket that? I can't remember. I think I socketed... Yeah, that was the one that was crooked on the board, wasn't it? 45 degrees. I almost worked out the equations for this myself. There's a channel, I'll stick the link to it up top left there. He recently did something using WinCouple to write some equations and program up a gal to replace one that had been missing. It was a fruit machine, I think he was working on a fruit machine board. Check that channel out. He's a really good guy. He's based up in Scotland, and he does nothing but primarily fruit machines. You know, both the digital ones with the digital LCD and also the manual ones where you pull the arm and the wheel goes round and all that sort of stuff. Very cool channel. So Magic, I think it's called. Check his channel out. But that's what I was headed with doing that. I started to write the equations in WinCouple, and I'm like, and I might revisit. Let me know, do you think I should revisit, and we'll reproduce that? Because this works, I can now use the logic analyzer and actually prove what I think I need to do in terms of address decoding. The ROM up here is easy, just looking at the main source code to see what address range it sits at, and anything else that's you know, controlled by that. I think primarily it's just it was the ROM and the Z8, not the ROM, that's the ROM. The ROM and the YM, you know, get the chip select or output enable from this. But anyway, we could recreate that, is the point. And that would have been the case if we couldn't, you know, if this wasn't working at all, and I wasn't, you know, and I couldn't get it working even with my guesstimations of the equations that might be required. I could just find another bootleg like this, one that does work a bit better, and logic analyse the you know, the connections around that there. Obviously labelled up all the ROMs here, a bit bodgy, the labelling, they're not perfect, but yeah, anyway, it's come out absolutely fantastic. A huge thanks to Glen over at CRG. Please check out Glen's channel. I can't thank you enough, Glen, for sending this, because I have thoroughly enjoyed it. It's been a lot of work, but I have enjoyed working on this. And yeah, the solder points, they don't come out that well on a board like this because, well, the pads, as soon as you heat them, you know, over 350 degrees, and you do need to be around that mark because it is, you know, double-sided. As soon as you heat one of these pins on a chip for more than about 20-30 seconds, you know, trying to unblock it with a pump or the desolder station, the pads just dissolve. They just dissolve. It's like it's, you know, they were manufactured to a price point, and it shows. Anyway, I do hope you found that interesting. Please see the links down below for Patreon coffee if you'd like to support the channel. I'll catch you in the next video.